Hey there, Sunny Scientists. Today we're going to read more about the sun. This passage is kind of long, so we're going to read it together. Maybe you've already read it once, which would be great. Read it the first time to get through the words. The second time we understand it more. Or you might want to reread it again after I'm done. Or you could even watch the video again to have me reread it to you. So you can either print this out, and if you can't print, pull it up on your screen and follow along with me as I read. When we're done with this, then you're going to answer the questions that are on Schoology. You can either print them or you can just write your answers on notebook paper and then add them to the discussion post. So right now we're going to go back and read about the sun. And if you want to print this, you can always color it if you want. So we have the description of the sun. The sun is a yellow dwarf star at the center of the solar system. It looks so much bigger than other stars because it is so much closer. So the closer it is, the bigger it looks. The 8 planets orbit around the sun. The solar system and the sun orbit around the center of the galaxy, the Milky Way. Even though the sun is a relatively small star in the universe, it is huge in relation to the solar system. Despite the massive gas planets like Jupiter and Saturn, the sun still contains 99.8% of the mass in the solar system. More than 1 million Earths could fit inside the sun, and about 109 could fit across the sun. So 1 million of our Earths could fit inside the sun. The sun is made up of gases like hydrogen and helium that smash into each other in the core and let out energy. And remember, we learned the core is where the hottest part of the sun is. The energy moves to the surface and leaves it as light and heat. This light and heat reach Earth in only 8 minutes. The sun's great weight causes it to have strong gravity. This holds its gases in a ball and the planets into their orbits. So the reason why it doesn't just go everywhere is because it's got gravity that keeps that heat in. The surface of the sun, the surface is the top part, or that part we see. The sun's surface is very hot, around 10,000 degrees Fahrenheit. The sun has a thin atmosphere called the corona, which we talked a little bit about yesterday. Its temperature is nearly 200 times hotter than the sun's surface. Sunspots, yesterday, dark patches that are cooler than the rest of the surface appear on the sun. The surface of the sun has bubbles, prominences, 8 giant loops, and sometimes stretch out from the surface. Explosions about the sun's surface make solar flares. Gases from these shoot out into space. The sun also sends out solar winds, streams of gas that flow through space. So a lot of this we discussed yesterday, and that's why we kind of read more than one piece of text about the same thing, is that we just get that information, we learn it, we understand it more. This can make auroras in the night sky on Earth. Remember we talked about that yesterday, those green lights from Polar Express? They are often bands of green, red, or purple light. So that would be a great thing, a great extension activity is to look up auroras. Research that, you see amazing photographs. The sun and Earth. Earth is 93 million miles from the sun. It is just the right distance away, so Earth is not too hot or too cold. People, plants, and animals can live on Earth. It takes the Earth 1 year to orbit around the sun. Here's the sun, takes us 1 year to orbit around. The seasons change as the Earth circles the sun. Earth spins around once in a day. From Earth, the sun appears to move across the sky. The sun's light only shines on half of the Earth at a time. Where the sun shines, it is day. Where it does not shine, it is night. The sun provides heat and light for the Earth. Its energy also stirs Earth's atmosphere to make the weather. It gives us food by helping plants grow. Earth would be a cold, dark place without the sun. It gives us the energy people need to live. So again, lots of things that we read about yesterday. Research. The sun has been studied by humans, astronomers, and scientists as long as there have been people around. Astronomers like Galileo and Isaac Newton studied the sun in the 16th and 17th centuries. They learned the planets orbit the sun due to gravity. Albert Einstein used the formula E equals mc squared to explain how the sun generated its energy. Arthur Eddington explained how intense pressures at the center of the sun could produce nuclear fusion and large amounts of heat and energy. Many space missions have observed and studied the sun, solar winds, and sunspots since 1959. The sun is expected to remain stable for the next 5 billion years. Good thing. So there are lots of facts in here, lots of names. Arthur Eddington, Sir Isaac Newton, Galileo, Albert Einstein, lots of names there. So if you want to research something, those are some other things that you could research, okay? Again, that was a long passage. You might want to listen to it again, or you might want to read it with mom or dad. So after you reread it or listen to me again, then you're going to pull up your questions and going back to find the answers. So for some reason, it starts at 11, 12, 13, 14, 15. Don't worry about the numbers, okay? If in Schoology you put 1, 2, 3, 4, 5, that's fine. If you do 11, 12, 13, 14, 15, that's fine too. So all of these answers are in your face, kiddos. All of them are in the text. So you just need to take your time, go back and look for them, okay? Which of the following best describes how the author organized the selection? That's sort of like what we're doing in reading right now. How are the passages connected? How did the author organize it, okay? All of them are in your face, so you should be doing just fine on them. And reread, answer your questions, and then post your answers in Schoology. You can always research, or you can go back on Epic Books. There's a whole bunch of different books on the sun.